We are going to focus on a very interesting topic called inter VLAN routing. See, between VLANs, switches cannot allow traffic to pass through. We learned that very strongly, we know it. Between different VLAN, traffic will not be allowed to pass through. When I have switches on when I have switches with many ports like this, by default it will be in VLAN 1 and all members of the VLAN 1 will be able to communicate. Because by default, all these ports are in same VLAN. But when I put them in different VLAN, for example, this 4 ports and this 4 ports, I put them in VLAN 10. These 8 ports connected device will form one logical switch, one virtual switch. This 8 ports forms one virtual switch. And the remaining ports forms another virtual switch. By default, all were in one single virtual switch called VLAN 1. But when I put these 2 ports in VLAN 10, that becomes another virtual switch. Now, if I try talking between these two, not possible. These two PCs cannot talk. Let's say the computer IP address is 10.0.0.1. 10.0.0.2. They won't talk. They will not talk. Even though they are very next port, they will not talk. Because this is in different broadcast domain, that is in different broadcast domain. Usually for a VLAN, the network will be different. For each VLAN, there will be different network. Let's say this is VLAN 1, this is VLAN 10. For all VLAN 10, I'll have a common subnet. For all VLAN 1, I'll have one common subnet. VLAN 1 I'm using 10, VLAN 10 I'm using 20. So this 20.0.0.2 and 20.0.0.1 will talk. But if this A and this B wants to talk, if A wants to talk to B and C, or if B and C wants to talk to A, not possible. Switches won't allow to communicate between VLANs. No inter-VLAN routing. See, between VLANs, what is needed? Routing is needed. 2 reasons. Number 1, each VLAN is in different networks, so you need routing. Number 2, each VLAN is a separate broadcast domain. So we have to find some way to do inter-broadcast communication, inter-broadcast domain communication, which is nothing but inter-VLAN routing. We need to find some way to make this communication happen. If they want to communicate, if this A wants to communicate to B or C, we call that as the inter-VLAN routing. How to do this? We can do like this. You can take any one of this port and connect it to a router. And this port will be in VLAN 1. We connect another port to the router, and this will be in VLAN 10. On this F00, you give IP address 10.0.0, maybe 10. See, VLAN 1 is in 10 network. So we give 10 as the gateway. So this PC will have gateway what? 10.0.0.10. And on this port F01, give IP address 20.0.0.10. So this both the PCs will have gateway 20.0.0.10. So whenever you ping from here 20.0.0.1 or 2, the PC will forward the packet to the gateway, which means it goes here. And then the router has got the routing table. We learned the routing table, how it is built in CCNA. The routing table is there. Now when the packet goes to the router checks the destination. The destination is 20.0.0.1. It knows 20 on F01. So it pushes the packet like this. It takes the packet in and checks the routing table. Here is a match for the destination, so it pushes the packet via F01. Now it is entering into VLAN 10 domain, so VLAN 10 members can now receive the packet. Using ARP, it will locate the MAC address of 20.0.0.1, and the packet now goes to 20.0.0.1. This is inter-VLAN routing, but this is not always possible. This is inter-VLAN routing, but this method is not always possible. Why? You see, some routers will have only 2 ports. Now you have used one port in VLAN 1, another port in VLAN 10. What if I have VLAN 20? I have some device in VLAN 20. I have IP address is 30.0.0.1, and I want this 30.0.0.1 to communicate to 20.0.0.1. This is in VLAN 20. But the router has got only 2 ports. One you have given for VLAN 1, another we have given for VLAN 20 to VLAN 10. VLAN 10 and 1 has already occupied the available ports on the router. For VLAN 20, there is no port on the router. There is no port. What will you do? That is why this method is not recommended. You cannot give each VLAN a port. Routers won't have that many ports. Routers will not have that many ports. Then what we will do? We will take only one port. See, it's only one port F00 dot 1 dot 2. We call this a sub interface. We take one physical port and subdivide logically into multiple ports. F0/0.1 is having 10 network, F0/1.2 is having 20 network. So this is actually not two physical link. It is actually only one link. Only one port. This is only one port. But logically we have subdivided into two ports. Physically it is only one port. Now, how can this one link carry multiple VLANs? Trunk. You make this port as a trunk port so that VLAN 1 can also use, VLAN 10 can also use. All VLANs can use. VLAN 1, VLAN 10, VLAN 20, all VLANs can use trunk port to go to the router for getting routed. Router only can do what? Inter-VLAN routing. Each VLAN is a broadcast domain, I told you. Each VLAN is a broadcast domain. And each port on a router has got a broadcast domain. Each port on a router has got a broadcast domain. So combining between two different broadcast domains is only possible through a router. In another word, inter-VLAN routing is only possible with the help of layer 3 network device, which is a router. So we have a trunk on the switch side, and on the router side, what we are going to do. See, if I have two switch, if this side is configured as trunk and if this side is auto, it will negotiate and form trunk. Or you can also configure trunk. So now what happens when VLAN 10 members send the traffic? When VLAN 10 members send the traffic, trunk port, before sending the packet out, it will put the VLAN number. And the receiving trunk port will remove the VLAN from the packet and deliver the packet to the PC. The sending switch trunk port encapsulates or inserts the VLAN. The receiving switch, after receiving, it knows that the packet belongs to VLAN 10. After knowing to which VLAN the packet belongs to, it will pop that VLAN ID and send only the IP packet. Now, if this trunk port is going to send the traffic, for example, I'm pinging from here to here. So this is the packet. Source IP 10.0.0.1. Destination IP 20.0.0.1. When the packet enters this port belongs to VLAN 1. Isn't it? Now, let's do one thing. This is VLAN 10. All other ports are VLAN, let's say 50. This is VLAN 50. All other ports are VLAN 50. Okay, VLAN 50. Now, when this packet goes out via the trunk port to the router, trunk port is going to add VLAN ID. Now, on the receiving router, there is no trunk port. I told you here, VLAN ID is added, and this trunk port, after knowing what VLAN it belongs to, it will remove the VLAN ID. But who will remove the VLAN ID here? Who will read the VLAN ID here? This is router. This is not a switch. So what we do is, when you configure a sub interface, we will say all traffic that is marked with VLAN 10 belong to this subinterface. All traffic that is marked with VLAN, no. All traffic that is marked with VLAN 50, all traffic that is marked with VLAN 50. You see, VLAN 50 is what it is marking and sending. I told you these ports are VLAN 50. So when you create subinterface, you have to say what VLAN traffic this subinterface will receive. So the packet is marked with VLAN 50. It is entering in. It's one single physical link, but two subinterface. The controller of this subinterface will take the ownership of the packet. Will claim the packet. Likewise, when you create this subinterface, you will say any traffic that is coming with a marking of VLAN 10. So now the traffic wants to go to 20. It checks the routing table. Listen carefully. It checks the routing table. It understands that the packet need to be sent via F0/0.2. F0/0. F0/0.2. Now F0/0.2 belong to VLAN 10. So what this router will do, it will put VLAN 10 ID, it takes the packet from VLAN 50, puts VLAN 10 ID and send it back to the trunk port on the switch. Switch reads the VLAN ID, understands that the packet belongs to VLAN 10 and delivers the packet here. You see, the router is doing partially the trunking job. But we have to tell the subinterface what VLAN the subinterface will be member. Without giving what VLAN the subinterface will become a member, you cannot assign an IP address. I repeat, whenever you configure subinterface, before configuring IP address, please give the VLAN the subinterface belong to. Only then the subinterface will operate. If you are using subinterface, definitely on the other end of the wire, it is going to be a trunk. Trunk is not going to accept any packet if it is not having VLAN ID. And trunk will also send the packet with the VLAN ID, which need to be known to the router. So, whenever you configure subinterface, before you give IP address, make sure you tell what VLAN the subinterface member. You see, you cannot configure trunk on the router, but you can say router subinterface F0/0.1. Any traffic that is coming into this physical interface with VLAN 50, you take it. Any traffic that is coming with VLAN 10, F0/0.2, you take it. Yeah, after routing, the right VLAN ID will be inserted before sending to the switch by the router. This is what we call it as inter-VLAN routing using method router on a sticker. You see, this trunk link is like one sticker on top of which the router is sitting here. That's why it is called as router on a stick. Router on a stick is nothing but connecting a router to one of the switch port, which is already a trunk, and having sub interface on the router with VLAN, using which traffic enters and get routed and traffic departures with VLAN tag attached to the router. Towards the switch trunk go back. I'm going to do this and show you now. Before that, how many of you understood, or is any questions from anyone? Inter-VLAN routing, do you have question? I'll use packet to schedule this. So this is the plan. I'm going to give IP address first to this PC. As it is written in the background, I'm going to 10.0.0.1. And the gateway is going to be 10.0.0.10. This is what I'm going to assign to the router's sub-interface. 10.0.0.10. Check the IP country, IP address, mask, and the gateway. Done. Likewise, ten. And then okay. Next, we will configure VLANs on the switch and assign the ports. Switch. On the switch ports, you don't need to say no shutdown. By default, it will be up. I'm going to say switch port mode access. I did not create VLAN, but I can do like this: switch port access VLAN 10. Automatically, the VLAN gets created and this interface gets assigned. Likewise, I'll say interface F02, which is this one. That need to be a member of VLAN 20. So switch port mode access, switch port access VLAN 20. Interface F0/3, switch port mode access, switch port access VLAN 30. Let's verify. Show VLAN brief. You can see these ports are in different VLAN. Now we need to connect a router if you want to ping between this. Two reasons this will not ping. Number one, they are in different subnet. Number two, they are in different layer 2 domains. They are in different VLANs. They are in different broadcast domain. So now, in order to connect between different network, and in order to communicate between different VLANs, which is nothing but different broadcast domain, you need a router. So I'm going to bring a router, connect to any port on the switch. Any port that you like. So it's going to give me F04. Now this F04 only you should configure as what? Trunk. Don't forget, on the switch side, you have to configure as trunk. So let's go configure it. Interface F0/4 switch port mode trunk. The interface is down because the router is not ready. Let's bring the router. What is the interface name? G000. First, bring the interface up. Bring the physical interface up. I'm going to use this as interface routing router. So I named it like this. You can give any name. I'm just giving some meaningful name. No shutdown you give. Don't do any other thing. Just come out of it. Now I'm expecting this to turn green. Wonderful. Let's go to the switch and check the trunk port. Show interface trunk. You can see F04 is trunking and trunking is on. And these are the VLANs it will allow. The default VLAN 1 and then the 3 VLANs that I created, 10, 20, and 30. Now on the router side, I don't have 3 physical interface, so I'm going to create sub-interface. That is why I have trunk on the other end. And these are the gateways I'm going to configure. G0/0/0.1. I'm going to give IP address 10.0.0.10. And this is our VLAN. You have to mention VLAN also. G0/0/0.2. 10.0.0, sorry, 20.0.0, 10. VLAN is G0/0/0/3. Dot is the sub interface. Dot 1, dot 2, dot 30.0.0.10. VLAN 30. Okay, so this is the plan. I don't know why my typing is like this today. Okay. So this one physical interface is going to be 3 logical interface like this. Let's do. Right now, when I say show IP interface brief, you see only one physical interface G000. But when I say interface G000.1, it creates the sub interface. Because the physical interface is up, the sub interface will also come up. The base, no, it should be up. And now you see, if I give IP address, it won't accept 10.0.0.10.2.5.50. It won't accept. Why? You should tell what VLAN this interface belongs to. So this is the command. Encapsulation .1q VLAN 10. And then you give IP address, it will accept. This is the sequence in which you should configure. First the VLAN and then the IP address. And where you are in the sub interface mode. Now exit from here. Another sub interface, the .2, encapsulation .1q20, IP address is 20.0.0.10. Next, interface 0/0/0.3 encapsulation .1Q30 IP address is 30.0.0.10. Now let us verify show IP interface brief. Look at this, look at this, look at this, look at this. One physical interface is subdivided as three logical interfaces. And check the routing table. You will have 10 on dot 1, 20 on the same physical interface but different sub interface, 30 on another sub interface. Now the ping between these VLAN members will happen. This is what we call it as inter-VLAN routing. Let me ping from here. Ping 20.0.0.1. You see, it's happening. Ping 30.0.0.1. See, we are able to ping from one VLAN member to another VLAN member. How do we prove that this is going through the router? You trace route and see. Trace 30.0.0. See, it first goes to the gateway. Whose address is this? It's router's address. The traffic comes from here to this sub interface and looks for 30.0.0.1. So it puts that traffic into this interface and goes like this. Before sending out, it will put the tag VLAN 30 and send so that this trunk will know to which VLAN member the traffic, the ping traffic should be forwarded. That's why you have to mention that VLAN number on the sub interface. See, it goes to routers 10.0.0.10. From there, it went directly to 30.0.0.1. So, without we having multiple interface for each VLAN, you can just use a trunk link and put the VLAN number on each sub interface. We call this as a router on a stick method. Inter-VLAN routing using router on a stick. But there is a drawback here. If this link goes down, no communication between VLANs. Not only that, traffic is going this way and coming out on the same path to go to other VLAN. So this link is going to be congested. If every computer wants to go to some other network, then both to and fro, usually the traffic will enter in one port and leave on the other port. But here the traffic is entering on one port and take a U-turn and leaves on the same port, comes like this and then goes like this on the same physical wire, which will be a bottleneck in a large network. That's one drawback of this router on a stick. So two drawbacks we have seen. One is the link failure. Just one link failure will stop all communication. Let's say this is your internet. You are connected to internet via VLAN 30. So you are not only using this router to go to other VLAN of your own LAN, your own office, you're also using this inter-VLAN routing to go to the internet. Now your internet is not available. When one single link goes down, you're not able to communicate to any network, local networks as well as the internet networks. Only within the LAN you can talk. Only layer 2 communication is possible. So another drawback is this. The traffic get processed, comes back, again get processed on the same switch and then goes. Too many times the same packet has been processed before sending to the final destination. So to solve this, what they do is, in this type of scenario, it is recommended to use a switch which can do both switching and routing. The switch that can do both switching and routing is called as multi-layer switch. So that it comes, if it is different network, get routed, inter-VLAN routing, boom, just one motherboard. But for that, what you need is not a normal switch. You need a multi-layer switch. See, this is called multi-layer switch. You see this type of switches. See, the icon is different. This switch icon is different from this. This is also a switch. But you see in the center you have a round, which means it can also do routing. Here you don't have a bottleneck. You don't have a single point failure. See, switches will not fail, but the links will easily fail. This link will easily fail. The switches won't fail. So if I keep the switch here, there is no need for a router. And you will not have this bottleneck wire. Right? That is what the use of multi-layer switch. You can reduce the number of hops. You can reduce the number of devices that processes the packet before forwarding to the final destination. You see, single time process. Boom, packet goes out. But that's not the case here. One time, two time, three time, and then goes. But here, when I replace like this, I no need trunk. When I replace just one switch only, single motherboard in the middle. Okay, now I'm going to do and show you inter-VLAN routing, but this is not a router on a stick. This is by using multi-layer switch. I no need to create this sub interface. Instead, Instead, I will create interface VLAN. That interface VLAN is what called as SVI, Switched Virtual Interface. So again, I'm going to create a virtual interface. On behalf of VLAN 10, I'm going to create one virtual layer 3 interface. And on behalf of VLAN 20, I'm going to create another virtual interface, which is a layer 3. See, this interface VLANs are not layer 2. It is layer 3 interface for VLAN 30. Okay, this is it. We are not going to create sub-interface. We are going to create layer 3 virtual interface called SVI. Switched Virtual Interface, which is nothing but VLAN interface, which is a layer 3 interface for each VLAN. But it is not physical. Switched virtual interface. It's not physical, it's virtual. Okay, let me first of all assign these VLANs to the appropriate ports. Hostname inter-VLAN routing using multi-layer switch. Interface F00. Is it F00? No, F00. F01. No, switches won't have 00. Switch port mode access. Switch port access VLAN 10. Hey, not VLAN 110. VLAN 10. Okay, next. Interface F0/2. Switch port mode access. Switch port access VLAN 20. Interface F0/3. Switch port mode access. Switch port access VLAN 30. Verify. Show VLAN brief. Now you can see that VLAN 10 is mapped to F01 is mapped to VLAN 10, 2 is mapped to 20, 3 is mapped to 30. You don't need this VLAN I accidentally created. If you want, you can delete it. Yeah, okay. But this is layer 2. You need to enable routing in first place. This is the command to enable. Very important. This is a multi-layer switch, right? Multi-layer means what? Layer 2 and layer 3. But it is a switch now, so by default it will not do routing. It will do only layer 2. Though it is layer 2 and 3, by default it will be 2 only. If you want 3, you can put this command so that you will have both layer 2 switching as well as layer 3 routing. Next step. Create VLAN interface. So for VLAN 10, I have created a layer 3 interface. Here I can give IP address 10.0.0.10.255.0.0.0 and another interface VLAN 20. IP address 20.0.0.10.255.0.0.0. Next. Interface VLAN 30. So on behalf of all the layer 2 VLAN 30 members, we are creating one layer 3 interface called SVI. Check the routing table now. Show IP route. You can see this SVI having networks. That's it. If you now ping, you will be able to ping. You see, it's going to gateway 10.0.0.10 and then to the final destination. Try pinging, it pings. You know, this proves that it is going through the routed engine, multiple hops. Goes to 10.0.0.10, which is an SVI of VLAN 10, and then get. We call this as inter-VLAN routing using multi-layer switch. Benefit: single motherboard processing, faster, no bottleneck. See, in this is a narrow path, just 100 meg or 1000 meg. It's very narrow. Motherboard is very high bandwidth than the cables. Some motherboards work in 100 gig. Some motherboard works in TVs. You see, not only that, the physical device. Here we have two devices. Here you've got only one device. So in the rack also, the space consumption is not much. Electricity consumption is also not much. Space consumption is also not much. Maintenance is getting reduced. You don't need to connect to two different device consoles. Just one console. You can check the VLAN as well as the routing. You see, in this you can able to see the routing table. You already see that, and you can also see VLAN table. Single motherboard, single monitor, single interface. Because it's a multi-layer switch, you can have both layer 2 and layer 3 function. That's the end of layer inter-VLAN routing in between two different VLAN communication using router on a stick and the multi-layer switch. We have seen advantage and disadvantage. What is the disadvantage of this one? Costly. The switch is costly. There's no other disadvantage. Any questions?